Okay, so we're having some technical problems with this computer. So we only have 4 more lectures and labs in Chem1B this semester.
Did you do 1 more lab?
4 more labs. 4 more lab periods and 4 more lectures. The final exam for Chem1B is scheduled for okay, so scheduled for Tuesday, May 29th, 8 to 11 a.m. And this final exam will be open book and notes. And the final exam will consist of 2 parts. So just like Chem1A, the first part will be a take-home portion, so that will be given out a week before the in-class portion. And for the take-home portion, you can work on that with other students in the class. And there will be, and the in-class portion will be the same length as a midterm exam, so that should take you about an hour and 15 minutes. You'll be given the entire 3 hours to take the in-class portion of the final exam. But I'm hoping you'll finish the final exam early. Okay, so on Tuesday in lecture, we discussed batteries. And what are the electrodes in a car battery? Yeah, so one is one electrode. What's the other one? Which one is the anode? So which one was the which one was which again?
Anode is lead.
Anode is lead. What is the reaction which occurs at the lead electrode in the car battery? No, that's what I'm asking. What's the reaction? We know that the anode oxidation occurs. So what is the reaction which occurs at the lead electrode? So what's the reaction that occurs? Okay, so what's the reaction which occurs at the lead oxide electrode? Okay, so let's spend a few minutes talking about electric cars. We know that electric cars run on lead-acid batteries. So in 1996, GM produced the first electric car. The range is 90 miles. Now, does anyone know what the range on the Chevy Bolt or Nissan Leaf is?
Isn't it like 190?
Is it like 50 miles?
No, the Leaf is more than that. The Chevy Bolt looks like at least 100. Here we go. 100
miles, so it's really not much better than the this GM vehicle from 16 years ago. Now note that the battery rating for these lead-acid batteries is 200 amp hours. Now, an amp hour is equivalent to what unit that we've looked at in electricity? So we have an amp hour. Okay, so an amp is equal to charge over time. So that's coulombs per second, or coulombs per time. And then this is time. So note that an amp hour is equal to a coulomb, a unit of charge. Okay, so really the battery rating of 200 amp hours is really the amount of charge which can be supplied from the battery. Now, when these batteries are made, based on the battery rating, you can actually calculate the mass of lead oxide, and sulfuric acid to make a 200 amp hour battery. So the way you do this is you can figure out the charge in a 200 amp hour battery. So 1 amp hour is 3,600 coulombs. 200 amp hours is 7.5 times 10 to the 5th coulombs. Now, based on that formula that we used on Tuesday in lecture, that the number of moles of electrons transferred is equal to charge divided by Faraday's constant. If we do that, that means we have 7.46 moles of electrons in this 200 amp hour battery. Based on that, we can figure out how many moles of lead oxide, and sulfuric acid are needed then. Okay, so based on the number of moles of electrons, for every 1 mole of lead, there's 2 moles of electrons. And how do we know that there's 1 mole of lead for every 2 moles of electrons? Which equation? Yeah, so from the half reaction, you're telling me that what was it again? You have lead plus, what was the half reaction? Plus do the 2 electrons go here or on the other side?
The other side.
Okay. Yeah, so note that there's a 2-to-1 ratio of electrons to lead. That's where we get that 1 mole of lead to 2 moles of electrons ratio. So based on that, we have 3.73 moles of lead multiplied by the molar mass. So based on the rating, we need 773 grams of lead. And that's almost 2 pounds of lead. So for lead oxide, we can do the same calculation. we end up needing 892 grams of lead oxide. Then for sulfuric acid, we need 731 grams of sulfuric acid. You add all that up, and that gives you the mass of your battery. Okay, so again, based on the battery rating, you can figure out the amounts of materials you need for that battery. Now, what's one problem with using a lead acid battery? Yeah, so we know that it's rechargeable, but it can't go through an infinite number of recharging cycles. Yeah, the reason we can't do it is because the lead sulfate falls off the lead and lead oxide electrodes. But one big disadvantage of the lead acid battery is it's very toxic. No, lead's not the only thing that's toxic. It's heavy. Okay, so really the goal is to find lighter materials to use. So let's take a look at this next slide. So new battery technology uses low atomic weight substances. So here's the lead acid battery. And then you can actually calculate the battery range based on the molar masses of the reactants and products. So again, based on this, you can pick the approximate battery range equal to the atomic weight of the reactants, of the reacting elements divided by the number of electrons produced in the reaction. So we take the lead plus the lead oxide plus the sulfuric acid, divide that by 2 electrons. That gives us a battery range of 321 AMUs per electron. Now a newer technology battery is a sodium sulfur battery. So note that sodium and sulfur have a total atomic weight a lot less than that of the lead acid battery. So note that the battery range for the sodium sulfur battery is 71 AMUs per electron. So what this tells us, if we compare the lead acid battery to the sodium sulfur battery, is that the sodium sulfur battery has a battery range about 4.5 times greater than that of a lead acid battery. Okay, so again, by using low atomic weight substances, we can increase the battery range. And here's another one. This is the lithium polymer battery. Now, a lithium polymer battery is not the same battery which is used in your cell phones or laptop computers. The anode in this case is this vanadium oxide compound. The cathode is lithium. And note that the battery range in this case is 150 AMUs per electron. So if you compare the lithium polymer battery to a lead acid battery, which one? The lithium polymer battery goes about twice as far as a lead acid battery, but the sodium sulfur battery goes twice as far as a lithium polymer battery. Okay, so note again, the lighter or the lower the atomic weight of these substances, the higher the battery range. Okay, so again, that's the goal for battery makers, is to use the lightest elements in their batteries. Okay, let's go to the next slide. Now here's the lithium-ion battery, which is used in your cell phones and laptop computers, and also used in electric cars. So the anode is made out of graphite. The cathode is made out of this substance, so note that it's a lithium, nickel, cobalt, aluminum oxide compound. Note that this compound here, it's lithium 1, nickel 0.8, cobalt 0.15, aluminum 0.05. So note that this is not a stoichiometric compound, which we've looked at in Chem 1A and up to this point in Chem 1B. So this is actually called a non-stoichiometric compound. And so note again that these ratios aren't whole number ratios that we've been looking at so far. Okay? So you may be asked, well, how do they make these kind of compounds? Well, you start with lithium oxide, and you can add small amounts of nickel and cobalt and aluminum. So you're actually doping the lithium oxide with small amounts of nickel, cobalt, and aluminum to make this cathode. Okay, let's take a look at the reaction at the anode. So you have lithium LiXC6 going to XLi plus XX Xe minus plus 6 electrons. So what substance is being oxidized at the graphite anode? So you have two choices. What are the two choices for the substance being oxidized at the graphite anode? If you look at this half reaction, it's either lithium or it could be carbon. So which substance is being oxidized at the graphite? The lithium or the carbon?
Lithium.
So you're saying it's lithium because okay, so let's take a look at the product side first. So what's the charge on lithium plus? Yeah. What's the charge on carbon on this product side here? Is 0. Let's go to the reactant side. So we have this lithium carbide compound